Hi, today we're going to talk about the quadratic formula, which is shown right here. Okay, and what we're doing is you're going to have a standard form of a quadratic equation, quadratic, degree 2. That means that there's going to be two solutions to this equation. Degree 2 meaning that you're seeing that this exponent relating to the variable. Two solutions. You're going to either have two real roots that are different, or you're going to have one real root that's duplicated, or we're going to learn today about imaginary pairs of roots. That's where the equation does not cross the x-axis. This part of the equation inside here that I wrote in blue, that's called the discriminant. That allows you to discriminate to figure out whether we're going to have this situation, that situation, or this situation. We'll get there. So, okay, let's go to the next, this first problem. Oh, all of these are going to have the a value of a significant leading coefficient there is going to be 1, just because it's easy. Let's move forward. Okay, so look, I have this equation to work with. It's set equal to 0. Anytime we're doing this, it's set equal to 0. A little spoiler alert, when you graph it, you're going to see that it crosses the x-axis at the value of x being 3 and 5. Our solutions are going to be 3 and 5. Okay, here's how we use the quadratic formula. So we're going to look at this leading coefficient here. So a is going to be 1. And wherever you see the letter a, boom, that's where you put it into the formula. Let's deal with the b. b, including the sign, this negative 8 in front of the x to the first power, there's your b value. And so wherever you see a b, that's where you place it. So that's where all those negative 8s come from. And c, including that sign, is going to be 15. So that goes right here where the c is. Right here where the c is. And, okay, so let's focus on inside this square root symbol. Let me erase all this stuff so you can, without the colors, so you can see what I'm talking about. So this here is a discriminant. See right here, look, b squared minus 4ac. So let's worry about what that turns into first. So let's see, that's going to be negative 8 squared is 64. And negative 4 times 1 times 15 is going to be minus 60. That's inside this square root symbol. Let's deal with the rest. You got a plus minus. Remember, there's going to be two solutions to a degree 2 equation. And negative 8 is a positive 8. And all this is 2 times 1 is 2. So, and x is equal to this mess. So, okay, x is going to be equal to, I'll put brackets, 8 over 2 is 4, plus or minus the square root is going to be, well, 64 minus 60 is 4, so it's going to be pretty because that's going to be a 2. We're still dividing by this 2 over here. And since it's plus or minus, it means that, here, I'll write it again. Let's make that a minus. Ooh, I didn't mean to erase that much. Minus. There's our plus. See, we got the plus minus, so we have two solutions. Let's work this down a little bit. So this is going to be 4 minus, well, that's 2 over 2, so that's 1. And 4 plus, the square root of 4 is 2. 2 divided by 2 is 1. So that's going to be 4 minus 1 is 3, and 4 plus 1 is 5. Which I told you that before. I'd said there was a spoiler alert on this. See, let's go above. See, right there in red. Okay, but what I need to emphasize is that see how this discriminant, well, which I rewrote over here, since this is a positive value, it means that we're going to have two different real roots. Let me slide that over a little bit. There we go. Nice, so we met this first situation here. So the next one is problem is going to meet this second situation where the discriminant is 0. Let's move forward. So let me give you a teaser, not teaser, spoiler. The spoiler is right here. Right there is see how it strikes it, that equation, and hits it only once? That's going to be a double root. Okay? All right, let's do the math now. Well, you can see that, whoops, let me be consistent about colors. Yellow. A, there's your A value. And let's get our B. And let's identify our C. C, there you go. And you put those values into here and into the quadratic formula. So look, we have the negative 8 again. So there's your 8 plus or minus. Now, this is the part that's important. 8 squared is 64. Well, negative 8 squared is 64. And then 4 times 16 is 64. You're subtracting it. So see, this turns into a 0. See what I wrote right over here. So you're going to have a duplicate real root on this one. Let's finish this up. So this is 2 times 1 is 2. X is equal to this mess. So X is going to be equal to 8 over 2 plus or minus the square root of 0 over 2. So that's plus or minus nothing. So that's going to be 8 divided by 2 is 4 plus or minus 0. So you're going to get X is equal to 4 minus the 0 and 4 plus the 0. So you get 4 and 4. Now some textbooks are going to say that the solution is going to be this. No redundant numbers in the set. But I'm trying to make sure that we understand that there's really 2 of them. It has to be because it's a degree 2 equation. There has to be 2 solutions. And as you see, it just glances. Boom. There's your X equals 4. Okay. Next situation. All I did is, no, this problem I made up separately. That's right. This one over here is when I altered the 15 and the 16 to create that glance. This one here, different equation. Here's the spoiler alert. See how this, when I graph this equation, look, it's coming down, but it doesn't cross the x-axis at all, which means there are no real roots. We now are going to enter the world of imaginary numbers. So, well, whoops. There's your A value. There's your B. And there's your C value. So, okay. Plugged all those numbers into the quadratic, and then here's the important part. I did not write over here the discriminant, so let's get that done. That's going to be minus 4 squared minus 4 times 1, because, the A, and the C was 5. So negative 4 squared is 16 minus 4 times 1 times 5 is 20. So you're going to get negative 4. Well, that means we're going to have complex roots. So let me use that value and put it into here. So you get the square root of negative 4. Let's see, negative 4 times negative 4 is a positive 4, plus or minus, and we still got to divide by 2. When you see the square root of negative 4, we have to think about this. The square root of negative 4 is going to be the same thing as saying the square root of 4 times the square root of negative 1. The square root of 4 is a 2, but here's the important part. The square root of negative 1, we call that I. That is an imaginary value. And so we're going to have this situation where it's plus or minus that. So this is going to turn into, whoops, I forgot to put the x equals. So you got x equals, you got 4 over 2, plus or minus, this is going to become 2i, divided by this 2 still. And so, well, that's going to be 4 divided by 2 is 2. Plus or minus these 2's cancel, so it's plus or minus this I. So then x is going to be equal to 2 minus 2 plus this I. There you go. Now, the components of this is called a complex number. And let me get rid of this. This part here is the real part. And this part here is the imaginary part. Always in pairs. You're going to have this real value plus or minus whatever this imaginary part is. Always in pairs. And that just makes sense because, you know, we have a degree 2 equation. That's it for this video. Thanks for watching. And if you got any comments, here's cpzuroff@gmail.com. Thanks for watching. Whoops, that looks angry. Well, it still looks a mess. Whatever, you got the idea. Have a good night.